Hello friends, welcome back to our channel Learning Bees. As you know, we have already started class 9 CBSE series, and in this, as you read by the title, today we are going to do science lesson number 1, matter in our surroundings. The lesson is very lengthy, so we are going to do it in two parts. This is part 1, and stay tuned for part 2. So let's begin. But before that, if you are new to the channel, do subscribe to the channel, press the bell icon so that you get notified whenever we post a new video. Like the videos if you find them helpful, share them with your friends. So let's begin. Matter in our surroundings. In this video, we are going to deal with 4 objectives. First, what is matter? Then second, what is matter made up of? Then third, characteristics of matter. And fourth, states of matter and characteristics of each state. So let's start. What is matter? Everything in the universe is made up of material which scientists have named matter. That means if you look around yourself, whatever things you notice around you, each and everything can be called as matter until and unless it has some mass and it occupies some space. For example, let's start with our breathing, the air that we breathe, the food that we eat, stones, clouds, stars, planets, plants, animals, even a small drop of water or a particle of sand. Everything is matter. For example, if there is a table in front of you, the table is made up of wood, a material, and that is matter. Okay, let's talk about the history of matter. Early Indian philosophers classified matter in the form of 5 basic elements, and they called it the Pancha Tattva, which constituted air, earth, fire, sky, and water. That means, according to them, everything in the universe, let it be living or non-living, was made up of these 5 basic elements. Ancient Greek philosophers, on the other hand, also had arrived at the similar classification of matter. Let's talk about the modern scientists now. Modern scientists have evolved 2 types of classification of matter based on their physical properties and chemical nature. In this chapter, we will deal with physical properties of matter. And in other chapters, following chapters in this second or third chapter, they are all based on chemical nature. So now we will only talk about physical properties. Physical nature of matter, isn't it? What is matter made up of? For that, we will do one small activity. Take a glass or a beaker half filled with water and add a teaspoon of salt or sugar, what you have available in your house. In that, dissolve it with the help of spoon. Dissolve the salt or water. What you will observe? Just mark the water level and then dissolve. The observations, what will be the observations? You will observe that the salt has disappeared and water level also did not increase. So where did the salt go? Isn't it? That's the question. So what had happened? Can you guess? Yes. When we dissolve salt in water, the particles of salt get into the spaces between the particles of water. So salt particles, one matter, and water particles, another matter. So the matter, salt, gets dissolved and it settles down in the spaces between the particles of water. Okay. So what we observe here, that matter is made up of particles, isn't it? Now what is size of particles? Let's understand that. For that, we'll do an activity. We will take 2 to 3 small crystals of potassium permanganate and dissolve them in 100 ml of water, as you can see here in this picture. What will happen? The color of water will change because of that potassium permanganate. The plain water has turned into potassium permanganate solution. Now we can take a small amount, that is 10 ml of this solution, and add it or dissolve it in another 90 ml of plain water and repeat this 2 to 3 times. What will happen? As you can see in this picture, the dilution has taken place. The potassium permanganate continuously dissolves in the new fresh plain water and new potassium permanganate solution is formed. But it is diluted, isn't it? So what this indicates? This indicates that the experiment shows that this just few crystals of potassium permanganate can color large volume of water, tanks of water. 1,000-liter tank also can be colored by the small crystals of potassium permanganate. So we can conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves and into smaller and smaller particles. That means the size of particle is very, very small. That is beyond our imagination. So let's now talk about characteristics of particles of matter. Already we have done this in these two previous activities. In activities 1.1 and 1.2, what we observed, that is first characteristic, particles of matter have spaces between them, isn't it? When we add salt or sugar in water, the salt particles or sugar particles go and settle down in the spaces between the water particles. There are many other examples. Potassium permanganate also. The particles of potassium permanganate go and settle down in the spaces between water molecules, water particles, isn't it? There are many other examples like tea, coffee, lemonade. We are adding one matter into another matter, dissolving one matter into another matter, and the solution is made, isn't it? So the matters are made up of particles and there is space between the particles. These all activities shows that there is space between the particles. The second characteristic is particles of matter are continuously moving. Now as soon as we drop salt particles into the water, immediately the salt particles reach the bottom of the glass or beaker and the whole water turns into salt solution or sugar solution, isn't it? This proves that particles are moving. One more example you can take. You just take one glass full of water and put a drop of ink inside it or a teaspoon of Dettol in the water. What will happen? The particles will nicely mix in the whole volume of water. How it happens? Because particles are moving. So second characteristics, particle move. And one more thing is there, when temperature rises, the particles move faster. That is also the thing. Because the kinetic energy is possessed by the particles, and this kinetic energy increases as temperature rises and the particles move or vibrate faster. So this is one more thing. Particles are moving and according to temperature they move faster. This intermixing of particles of two different types of matter on their own is called diffusion. What is diffusion? Intermixing of particles of two different types of matter. For example, salt into water, ink into water, potassium permanganate crystals into water. So this is called diffusion. So what is diffusion? The intermixing of particles of two different types. I told you, for example, salt into water, ink into water, potassium permanganate into water, Dettol into water. And diffusion becomes faster on heating because kinetic energy increases. Now the third characteristic is particles of matter attract each other. There is some force of attraction between the particles of matter. Now this important thing we can prove by doing one activity. Make 4 groups of children. Each group will have 5 children, as you can see in this picture. Okay, the first group will stand like this. They will hold each other's hand tightly and hold the arms at the back very tightly and stand. The second group, what they will do? Just hold the palms of each other and make a chain. The third group will just touch the fingertip of their partner and stand. And the last fourth group, what they will do? They will try to break these chains of group 1, group 2 and group 3. Which group will be easier to break the chain? The third group will be easier to break, isn't it? Because they are not holding the arms or hands tightly of each other. They are just touching the tips. So the force of attraction is less there. And the second group, they are holding each other's palm. So little more force will be required to break that second chain. And this first chain, as you can see this in this picture, it will be most difficult to break this chain because they are closely tight. They are holding each other's hands at their back, each other's back, isn't it? So it is very difficult to break this chain. And now if you imagine, instead of children, think about the particles of matter. The same way the particles of matter are existing in their state. That is states of matter that we are going to do afterwards, after this slide. So we can say that in one state of matter, the particles are very closely and tightly held and they attract each other. Force of attraction is more. The second type of matter, the force of attraction is little less than this. That means they can be broken with less force. And the third one is another type where the force of attraction is very negligible and the chain can be easily broken. So the three characteristics we learned about matter. Now we will talk about states of matter. As we have done in earlier classes, we know that there are three states of matter: solid, liquid and gas. As we have done in the previous slide, this activity, that was quite clear from that only, that there are three states of matter: solid, liquid and gas. In that, the first group was solid, the second group was liquid and the third group was gas. These states of matter arise due to variation in characteristics of particles, isn't it? The particles are loosely held in gases. The particles are tightly, with full force of attraction, they are placed, that is in solid, and in liquid it is, the force of attraction is less than solid and more than gas. So we will now understand these three states of matter and their characteristics in details. First, solid state. Now if you look around you, so many solid things you can see: notebook, pen, needle, wooden stick and many other things. All these above examples are solids. Now we can observe that all these solids have definite shape. Their shape doesn't change, isn't it? Distinct boundaries also they have, and they have fixed volume. Fixed shape, distinct boundaries and fixed volume. And they have negligible compressibility. We can't compress them. Even if you put a lot of force, solids don't change their shape. They may break, isn't it, under the force, but they can't, it's difficult to change their shape. So we can say that they are rigid. So rigidity, definite shape, fixed volume and distinct boundary, negligible compressibility, these are all characteristics of solid. Now we will talk about the second type of matter, that is liquid. Now again look around you. Water, cooking oil, milk, juice, cold drink, these are tea, coffee, these are all liquids. Now these liquids, what is the difference between solid and liquid now here? The force of attraction between the particles of matter, isn't it? The solids, more force of attraction is there. And in liquids, the force of attraction is less, there is space between the particles. So there is no fixed shape. You can see water. Water takes any shape. If you pour it in bottle, it will take bottle shape. If you pour it in plate, it will take plate shape. So the shape changes. So no fixed shape. But have fixed volume. Volume remains same. Wherever you pour it, volume remains same. They take up the shape of container in which they are kept. Liquids flow, isn't it? Liquids flow and change shape. So they are not rigid. So rigidity is not the characteristic of liquid, and they are called fluids. Solids and liquids can diffuse into liquid, means mix. Diffuse means mix. We have done it earlier slide. isn't it? Solid means salt, for example. It diffuses in liquid. Liquids also diffuse in liquid. For example, ink drop, isn't it? Dettol. The gases from the atmosphere also diffuse in water. Now, how come this? Do you know aquatic plants? Yes, aquatic plants, they live in water. They also breathe, isn't it? Yes, they need oxygen. Plants need carbon dioxide. Is it carbon dioxide and oxygen present in water? Yes, they are diffused in water. That's why aquatic plants and animals can live in water, isn't it? The gases, especially oxygen and carbon dioxide, are essential for survival of aquatic plants and animals. Solids, liquids, and gases can diffuse in liquids. The rate of diffusion of liquids is higher than that of solids because liquids diffuse faster because the space between the particles is less. We know that. This is due to the fact that in liquid state particles move freely and have greater space between each other as compared to particles in solid state, isn't it? Now we will talk about the third state, that is gaseous state. For that we will take this syringe. These three syringes we have to take, 100 ml syringes. Close the nozzles by a rubber cork. Remove the pistons of all syringes. First syringe, keep untouched. Don't fill anything in that. Second syringe, you put some water. And in third syringe, you put some solid, like small pieces of chalk. And then insert the pistons of the three syringes and just press. What will happen? Compress. Try to compress. Which syringe will be easily compressed? Yes, right, the first one. Because nothing is there, it is empty, first one. Actually air is present in it, isn't it? So here it is proved that air is very easy to compress, then water, then solid. Second and third piston, it is very difficult to compress. So this is the special quality, special characteristic of gas. Gases can be compressed. Gases are highly compressible as compared to solids and liquids. The liquefied petroleum gas, that is LPG cylinder in your kitchen, that is the best example. Then oxygen supplied in hospitals, that is another example. These are all compressed gases. Tons, kgs of gases are compressed in small cylinders, isn't it? Easy to transport. Then CNG, fuel vehicles. All these are examples. So due to high compressibility, large volume of gases can be compressed into small cylinders and transported easily. We come to know about what is being cooked in kitchen, isn't it? When you are sitting in your bedroom or study room doing study and your mother is cooking something very delicious, you come to know immediately. It reaches to our nostrils. How it happens? The particles of aroma of food mix with the particles of air spread from the kitchen. That means gaseous state. Gas particles have a lot of space between them. They have negligible attraction. Forces of attraction is very less. That's why they move very fast. Randomly they are moving. That's why the aroma reaches us within no time, isn't it? The smell of hot cooked food also reaches to us as compared to cold food. Now, due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. So this is the special characteristic of gas. You can see here about how the gas, solid and liquid particles are compact. In solid they are compact, in liquid a little space is there, and in solid very negligible force of attraction is there, more space is there, and the particles are moving randomly, isn't it? In gaseous state, the particles move about randomly at high speed. Due to this random movement, particles hit each other and also walls of the container. The pressure is exerted by the gas is because of this force exerted by gas particles per unit area on the walls of container. That's all for today, guys. I hope you understood this part of the lesson. The second part we are going to do in second video. Stay tuned for part 2. So guys, like the videos, share the video with your friends, and of course don't forget to subscribe. One more thing, please comment on the videos. If you have any doubts, we are always ready to resolve your doubts, and also all these suggestions are also welcome. We'll definitely in work out on your suggestions. Okay, thanks for watching, guys.